Okay, here is where we take the transversal and the two lines it's crossing through, and it gets more special because the lines that the transversal is crossing are now parallel. And when these lines are parallel, it creates a special relationship between the angle pairs that we've been practicing identifying. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So very special things. We can do a lot of math knowing that. So those will be congruent. So in this picture with these parallel lines, you can tell that they're parallel because these little arrow markings. 2 and 6 are corresponding, and so they would be congruent. And when we're doing a proof, we're going to kind of shorten how we write this. So we have like a little spot to put this in shorthand. And so we'll say if lines parallel, then corresponding angles congruent. So as we're doing proofs, we would write that to shorten it down. That's the corresponding angles theorem. The alternate interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So in this picture, 4 and 5 would be congruent. So if lines parallel, then alternate interior angles congruent. So there's two of them. Here's the other two. If lines are parallel, or if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. They're not all congruent though. So here we go. What I meant was the next one. Same side interiors, those are not congruent. So my shorthand, if lines parallel, then alternate exterior angles are congruent. And it's very important that you realize, the lines have to be parallel first for you to say this. So we have to look in our picture and see that they're parallel in order to use the fact that 1 and 8 would be congruent. And then this would be the reason we would say to be able to say that 1 and 8 are congruent. The fourth set here, these same side interior angles or consecutive interior angles are going to be supplementary. And notice in the picture, a lot of the time you can even, it's kind of a hint to even look. 3 and 5, you don't want to go by what the drawing always looks like, but 3 is acute and 5 looks obtuse, and so, we don't think that they're probably not going to be congruent. They are supplementary. And same side supplementary is kind of how I remember that. That is the one pair of angles that we learned that will not be congruent here. So we're going to say if lines parallel, then same side interior angles supplementary. So you can abbreviate that pretty well. So here we're going to use some of these rules. It says if measure of angle 7 is 75, so I'm going to go ahead and put 75 down here. It says find angle 1, 3, and 5. So we're trying to find 1, 3, and 5. Tell which postulate or theorem you use in each case. So I could find angle 5 right now. That one's the one I kind of spot the fastest because it's the vertical angles. So angle 7 and angle 5 are vertical angles, so they are congruent. So angle 5, 75 degrees. So that's kind of how I know using vertical angles congruent. 7 and 3 are related because they are corresponding angles. So 3 and 7, their relationship is that they're corresponding angles. So I know that angle 3 is 75 degrees because it is a corresponding angle with angle 7 and corresponding angles are congruent. So I'm not writing this as formal as I would write in a proof, but just kind of explaining how I know. So then 7 and 1, the way that they are related is that they are alternate exterior angles. So I know that angle 1 is 75 degrees by the alternate interior or alternate exterior. Those are alternate exterior angles. So using the alternate exterior angles theorem, I'm able to say that angle 1 is 75 degrees because it's alternate exterior with angle 7. So I'm just going to add angle 1 and 7 here just to say those were the alternate exterior angle pair that I was using. On this problem, it says the measure of 3 of the numbered angles is 125. Identify the angles and explain your reasoning. So if 125 is right here, I know that angle 1 is 125 degrees because vertical angles are congruent. That's why I know about angle 1. I also know that angle 7 would be 125 degrees, and that is using the corresponding angles postulate that we looked at where the corresponding angles were congruent. And I could also know that angle 5, and it's funny that this was the last one I noticed because those alternate interiors are my favorite ones. 125 and 5 would be alternate interior angles. So angle 5 is 125 degrees because of the alternate interior angles theorem. And then the last one is just to find the value of x here. And so the 113 is up here, and this is over here. So our transversal is this line. The transversal is always going to touch both of the angles. So the green line here is my transversal. So let's figure out how they're related. The green line, they're on alternating sides of the green line. So I'm going to think about, are they alternate interior, alternate exterior? They are outside of these lines, therefore they are on the exterior. So these are some alternate exterior angles, and I know that they're congruent, so I'm going to set them equal to each other. So 113 equals 3x minus 4. So then I'm just going to solve. I'm going to add 4. 117 equals 3x. Divide by 3. 39 will be x. There's more videos with solving problems like this that I might add from other notes that I've had in the past, just in case you would like to see more of these samples.